Morning everybody, Gary Porter again. I've now completed the PC board. I got all the parts in and I got a couple more pieces to add and then I'll be ready to turn it on. I hope this schematic can come out okay, but I got an NE55 timer here. The pulses come out of that. I go through an inversion, then that goes to a counter here. I had a problem with the counter. I was trying to decode with this NAND gate and then reset the counter. I eliminated the NAND gate here from the schematic and I grounded pin 9 on the counter. Then the counter output automatically resets. That's what I was trying to do. I didn't really need to reset it. Now the decoder out here decodes the 10 outputs, and then they go through, they are a very wide pulse, and you don't want to have a wide pulse to your FET. You want to be able to control it and have any width you want very narrow pulses to the FET. You don't want to burn them up or whatever. And so now I put that through some 74C 244s, which are a 12-volt chip. Then they have an enable line. So I've got two groups of, well, 3 chips are used with the enable controlling the pulse width. I take the NE55 timer output, bring it through one of these 244s, and I can actually bring it back up to the enable for these 3 chips here, or I can bring it back through the same 244 again to give me a delay on when the pulse occurs inside the square wave here. And over here I've got a push button switch that's used to charge the caps, and that's it. And so the only change I had to make to the board was I had to cut the trace to pin 9 and ground pin 9. That's it. The entire board works, and so far. And let me go down here and see if I can't show you the board. The board is right here, and I got the 12-volt battery tied to it, and the entire board running to the FETs with the square wave is draws about 30 milliamps, between 30 and 40 mils at the most. So it's about, a little less than a half a watt to run the entire front of this board. And these caps here are the positive side, and then these caps here are the negative side. Right now I've got 100 microfarad 350 volt caps in there, and these FETs switch on based on the counter output, and the even pulses do the negative, the positive dump. That would be, so this one dumps into the primary, back EMF recharges these, and then next the positive one dumps in, and then that back EMF recharges these. So each of these caps gets 5 back EMF pulses prior to its discharge into the primary. That's the goal. You may need more, I don't know, but I do know that 3 pings on a coil will charge a cap up to about 150 volts. So if I get just 1/10, will be 15 volts for each of the 5 pulses. So that, this thing, my goal is to get these caps to remain charged, not draw any energy from the 2 batteries, be able to take, over here I've got a positive regulator tied to a coil, and that's going to be in the secondary of the transformer. That energy comes back, has to produce less than a half a watt to run the entire board. And the caps, after they're initially receive their charge from the 2 batteries, then the batteries can be disconnected, the board will be self-running, and you can adjust the level of voltage by simply changing the size of the cap here. The smaller the cap, the higher the voltage, and that's one method of regulating. You can also use resistors in the cap area, whatever. So anyway, there's going to be 10 pulses bouncing back and forth, negative, positive, negative, positive, negative, positive, and then we feed back the energy. The actual transformer could be anything. Could be Tesla coil, could be Rodin coils, anything you want. It doesn't matter. And the amount of energy you can eventually work this thing up to it's unlimited, and all off a half a watt. So if this works, it's going to be pretty awesome. So this is as far as I've gotten. I'm ready to. I've got to wind a transformer too, and I got to add my parts for my 2 regulators here. And just check that out, and we'll keep you posted. Anyway, have a good day.